Hello, this is HKMath. At least that's what I like to call myself when I'm busy having fun with mathematics. Today, I want to look at a process called completing the square. And this process can be used to factor quadratic trinomials. It can also be used to solve quadratic equation, and it can be used to help draw the graphs of certain parabolas, circles, ellipses, and hyperbolas. So it's a process that is very useful to know, but it's not always easy to understand. In fact, the process involves taking half of the coefficient of the middle term of the quadratic and squaring it. Take half of the middle term, or the coefficient of the middle term of the quadratic, and square it. Take half of the coefficient of the linear term and square it. What on earth are we talking about? What do we mean when we say we're going to complete the square? So I'm going to take a quadratic trinomial that is already a perfect square, and I'm going to show you why. What I am using is an applet from the National Library of Virtual Manipulatives .Utah State University Educational Institution, EDU. If you would go to Algebra tiles in the algebra strand, you can use those tiles to multiply and divide polynomials. And here I'm going to use the tiles to illustrate completing the square, or making a perfect square. So here's our polynomial, and if you would write it down, it would be really nice. I'm going to click on x squared. So x squared is 1. The quadratic term is x squared, or 1x squared, plus 4x. So I'm going to click on the x term, and the last one, or the constant term, is plus 4. So note that we have 4 as the coefficient of the linear term. And note that that tile is the same length. That tile has a length of x, and so does the square tile. It has a length of x. This is an x. This one is an x by x tile, and this one is an x by 1. And I'm speaking of the dimensions. x1. And you'll note that it's the same length, or width if you want to call it, as the 1 tile. And the 1, or unit tile, is 1 by 1. So if we were going to make a perfect square, which means we're going to make a bigger square now that uses all of these tiles, because this is a perfect square. Now, see where that half of the, you're going to see where that half comes from. You see how we're placing two X tiles here. So we need half of them placed here. We're going to place the other half here. So there is one, and see how half fits nicely? And it's almost logical that you would have to do that. But when you look at it algebraically and you take half of the linear coefficient, that isn't the same as what I see going on here. I can easily see that I need to split the linear terms in the number of linear tiles in half. And then I can place my 4 in here, and I have a perfect square. What is that perfect square? X plus 2. That's the length here. 1, 2. Notice what it is here. A length of x plus 2. Notice what it is here. A length of x plus 2. And notice what it is here. A length of x plus 2. So this is a perfect quadratic trinomial. It's a perfect square, and it is the square of x plus 2. Now, what would happen if we took all of this and jumbled it up and it became x squared plus 4x plus 6? So look at what happens now. I've got to add 2 more of these. So we already made that perfect square. There is no way we're going to get a perfect square out of this unless we end up with something left over. So we're going to say that it's this perfect square. And what we've done now is added plus 2. So this quadratic trinomial is this perfect square, and you've got to add on 2. You've got to add on 2. Now, we're going to take a look at x squared plus 4x plus 2. This is not a perfect square because you are short 2. So this trinomial, which is x squared plus 4x plus 2, can be written as the sum of x plus 2 squared, quantity squared, but we have to add on minus 2 because we are short 2. I am hoping that this will serve as an introduction to completing the square, which I will address in my next video. But this was designed to help you see that we take half of our linear tiles, and half of that would, in this case, would be 2, and we square it. And that's where the 4 comes in. So this is real important. Have the coefficient of the linear term and square it. That makes a perfect square. Hope this will help you when you're completing the square in the future. Thank you very much for your attention. See you next time. Bye now.